This is the fifth in a series of videos on confidence intervals and means. And the first thing I want to talk about is when you're doing confidence interval for means, the question is under what conditions are your inferences more likely to be correct? So, in other words, when will your results be approximately correct? And it turns out there's three different key conditions. And the first one is random. And the second one is normal. And the third one is independent. And let's talk about each one of those in turn real quick. What do we mean by random? What we mean is that what your results were produced either by random sampling or random assignment, if it was an experiment. So even though random sampling usually talks about when we're doing surveys and random assignment experiments, the condition of randomness is the same in both, right? To the degree that your sample or your assignment is truly random, we can say that your results will be approximately correct. The second one is normal distribution, and that is that either the underlying distribution is normal or an equivalent condition is the sample size is large enough. Remember, from the central limit theorem, which is extremely important, the central limit theorem states that even if the underlying distribution isn't normal, if you take a sample size large enough, x bar, the estimator x bar will be approximately normal. And the last one is harder to think about, but is also very, very important, and that is that individual observations are independent. And let's think about when is that violated, right? A simple example when independence is, let's say you were doing a sample of days and you wanted to know you were studying temperature, right? And let's say you took a month at random, right? So let's give this some flesh, right? Let's say you were looking at the years 1950 to 2013, and of all those months in those 63 years, you were going to pick a certain number of months at random, and then you were going to look at days within the month. So the question, are days within a month independent observations? Think about what you think. Days within a month. Are they independent? And the answer is no. What we know, they're not independent, because what we know about temperature is that temperature often runs in streaks. We talk about hot streaks and cold streaks, and that's actually a physical phenomenon in weather. So if you took a month at random, days within the month would not be independent. That would be violated. So let's think about how these might be violated. A failure in your sampling would violate randomness. A sample size that's not large enough or a distribution that's not normal will violate the normal distribution. And independent observations, when observations are not independent, then obviously that one's violated. So these are important conditions for your results. There's also a very important term in statistics that's introduced for the first time in this chapter, and that's the idea of robust or robustness. And the question is, we say the results are robust or are not. And here's the key. Whenever you do statistics, you have to make lots of assumptions. Robust results do not depend on those assumptions being exactly true. That's the idea of robustness. So let's say that if you had a procedure and it true under certain conditions, but the conditions were violated, they would not be true at all, then those would not be robust. So let's see if we can figure out a definition for a robust or robustness. So we say a procedure is robust if the results are fairly accurate, under conditions where your assumptions are violated. Let me spell violated correctly. That's what we mean when a procedure is robust. So, for example, if you were trying to predict X bar, for example, a confidence interval for X bar, and let's say that under certain conditions you got results 200 to 205, but if you changed your assumption slightly, you got 180 to 200. These are actually very different results, and we would say the results are not robust because if we change our assumptions, we get very different results. And this is not a there's no hard rule about what's robust or what's not robust, but it's something very, very important when we do statistics.